Hey there, Math 112 fans. Going to do the first part of this quiz 2 prep. This is, I strongly would encourage you to attempt this problem on your own as you're preparing for quiz 2. This is the winter 2019 problem 2 from my exam archive. So the key things here is we're practicing reading for those of you struggling with this skill. Let's read the question, see what it's about, and find that function. Then we'll translate. Then we'll make appropriate conclusions. So we're going to continue. This is the main theme of this thing I want you to prepare for in quiz 2. Okay, you sell things. The functions for marginal revenue and average cost, both in dollars per item, are given by these functions. So right away, things should be jumping off the page for you. We know this. Marginal revenue, which is the derivative of total revenue. So in your head, you could be thinking, this is the derivative of total revenue. And we have average cost. And we should be thinking, okay, average cost is total cost divided by Q. So if we want a total cost, we'd multiply times Q. That's how you use these definitions that we've been, working on for a while. You've actually used this one a number of times in the homework. The homework often calls this C bar, but you've seen this terminology many times. Okay. Now what are we going to do? There's a little discussion of units. We don't do as much with units as we used to, but that doesn't affect what we're about to do. There is a typo. This should say 1,000 items. Anyways, okay, so here we go. So is total revenue concave up or concave down at Q equals 4? So what is the question about? The question is about total revenue. That is our original function. So the first thing, in this case, we don't actually have to do this, but I'm going to do it anyways. The first thing you do is you could write down total revenue. Now you might say, well, I don't know what total revenue is, but you just learned how to do it. So you could do the antiderivative of this. You can do this problem without doing this, but if you're following the strategy of write down the function, you have to realize they gave me the derivative. I need to go back. That's what we're practicing now. And you should remember that total revenue at 0 is 0. So this has to be 0 as we discussed in class. Okay, so that's the total revenue. That's what the question's about. Okay. So that's the part where you need to know our skills in order to go between the functions. Okay, so next, concave up. Concave up is talking about the second derivative. Now, you don't actually have to set the second derivative equal to 0 because it's not asking for everywhere it's concave up or down. It's just asking about 4. And so it's asking, is the second derivative positive or negative at 4? So we need the second derivative of this. Now the first derivative, and this is why I said you really didn't need to find the formula for this, because the first derivative is 50 minus 2q. And that means the second derivative is negative 2. So we could have done that. We could have realized that the second derivative of what we want could already have been obtained quickly. So finding this was a waste of time here, but I did it anyways. Okay, so your conclusion here is that this is negative. Now, an interesting thing about this problem is it's always negative. And so it doesn't matter that it's at 4 or anywhere. It's always negative. That means it's always concave down. That means it's part of a frown. Now we should know that because it's a parabola. So there's lots of reasons we would have known this. But the fact that the second derivative is negative tells you it's concave down. So there's an example of reading what the question was about. It was about total revenue. Seeing that it was about concave up and concave down. So we took two derivatives of total revenue. And then seeing if it was positive or negative. That was the appropriate conclusion. This time I did not draw the number line because it wasn't asking me for the entire everything. In this case, if you drew the number line, it's always negative. So it's always part of a frown. Okay, let's play the game again. Find one positive critical value of average cost. There's our original function. That's what the question is about. So the first thing we're going to write is average cost. So this is just general problem solving that I hope every one of my courses has before they leave. Now, if you know you're going to do calculus, you would rewrite that as 30q to the negative 1. You'd write 2. You'd write plus q. That's your starting function. That's what it's about. And then it says use either the first derivative number line or the second derivative test to determine if it gives a local maximum or minimum. I always allow students to do whatever they want to make appropriate conclusions. But the moment you see local max and min, you should be thinking, I need to find when the first derivative is 0. The first derivative of what? The first derivative of whatever the question's about. Okay, so we're going to do that. So we get negative 30q to the negative 2 plus 0 plus 1. And then we need to find when that is equal to 0. Now this should look familiar because we solved almost an identical thing on the homework and on exam 1. So this does require some solving. This is my advice about multiplying both sides by q squared. This is one of my bits of solving advice. Now in this case, when you multiply everything by q squared, this becomes negative 30, this becomes q squared, and this remains 0. And so you get q squared is 30, and you get two possibilities. Q is plus or minus the square root of 30. Now, I probably would make the numbers nicer here. Back when we gave this test, we did more stuff with decimals, but don't let that bother you. I mean, it's a couple button pushes, and we're there. So this is approximately 5.47722. And again, back then when we talked about units, we had students say, hey, if you're going to thousands, you need to go this far. Again, since that's not an emphasis of our homework, that won't be an emphasis on our test. But I hope that that illustrates a few things. Just a second, I'm going to pull something up. Okay, now, we haven't done the analysis yet. So let's do the analysis game. So I'm going to draw a number line and ask myself, okay, there's this one place, 5.477. There's also a place negative, but since we're doing this business example, so we don't need to think about that, but we just need to think about what's happening before and after. And so what I'm talking about is this derivative. Before you get to 5.44, is this positive or negative? Now you can't plug in 0, because that doesn't make sense. But you can plug in like 1. If you plug in 1, you're going to get negative 30 plus 1, which is negative 29. So at 1, it's negative 29, which means everywhere over here it's negative, which means it's going downhill. What happens if you plug in something larger than 5.477, like 100? It's going to be positive. If you can't see that, you can actually compute it and say 30 over, I don't know what you want to plug in, 10 squared. There we go. We want that to be negative. So let's do, negative 30 over 10 squared, which is 100, plus 1. Is that positive or negative? It's positive. So it's going to be uphill. So the fact that it's downhill and then uphill means it's a minimum. If you don't like that, there's another way to do it. You could find the second derivative and see if it's, and you're hoping it's concave up in order to match with this. Now the second derivative is, let's see, this is going to be q, so it's going to become 60q to the negative 3. And that's going to always be positive. In particular, it's positive at this value, so it's part of a smile. Both of those things confirm that it's a local minimum. Okay, last one, maximum profit. So what is the question about? It's about profit. So step 1 is we write profit. Profit is revenue minus cost. Now in this case, we know the revenue, I found it earlier, is 50q minus q squared. The cost we haven't written yet, but we should know it's Q times average cost. So if I multiply times Q, I get 30 plus 2Q plus Q squared. And so I can simplify that. Let's do it. So it's going to be 50Q minus Q squared minus 30 minus 2Q minus Q squared. And if I clean all that up, it's negative 2Q squared plus 48Q minus 30. I want to know when it's maximum. So now we have the original function. The original function here is profit. That's what we're being asked about. I want to take its derivative, negative 4Q plus 48. Solve for Q, which I think is going to be 12. And then what's the question? What is the maximum profit? Now, we should know, we should expect that it happens at 12, but the question is not asking for the quantity. It's asking for the actual profit. If you wanted to analyze it more closely, you could plug in a number less than 0 and see that it's positive, the derivative is positive. Plug in a number greater than 12 and see that it's negative, so it's uphill and downhill. That just confirms that this is indeed a maximum. If you don't know what I'm doing there, ask in the lab, ask them in the discussion board. This is just confirming this. But the last piece of the puzzle is it's asking for maximum profit, and so we're going to plug this in here and see what we get. So let's see what we get. Negative 2 times 12 squared plus 48 times 12 minus 30. So we would have 258. So there's our first example. I would encourage you over the long weekend to try some of the other ones. I think I'll do kind of a video like this every day or so. So I'm not going to do each one right now, but I'll do the next page maybe in a day. I'm hoping this kind of gets this focus. So as you step back, I want you to get to a place where you see all of those questions as the same and not as different. Each question said, here's a function. I want you to analyze it and tell me something about it. The first one was about total revenue. It was asking about concavity, so I needed the second derivative of total revenue. The second one was about average cost. It was about a local max and min, so I needed the first derivative of average cost, set it equal to 0. The third one was about maximum profit, so I needed profit. I need to take the first derivative, set it equal to 0. To me, those are the same types of questions. I don't want you to think of each one as a dramatically different thing. All right, I hope that helps.